Should be seeing my slides now, right?
Yep. Yes. Yep.
Okay, so thank you, Mohammed. So happy to be here. Actually, I really enjoyed this workshop. I've been attending it since 2018, I guess. It was back then, it was in Montpellier in France. And here I am today giving a keynote talk. Very excited. So thank you for inviting me. I'm going to spend some of your time today talking about how we do refactoring related research at JetBrains and the way how ideas become features in IDEs. I hope you will find something useful in our experience, and I'll try to reflect on the takeaways for the research community. So a quick intro. I come from JetBrains, a company that is responsible for bringing you IntelliJ IDEA, PyCharm, UTrack, TeamCity Space, Kotlin, and other IDEs and tools for teams. Currently, we have more than 10 million users, and the number is growing every year. We are an international company of more than 1,500 people working from 9 different offices all around the world. And aside from multiple product teams, we also have a research department containing about 20 labs now, dedicated to various topics from nuclear physics and neurobiology to, I don't know, mobile robots, cryptography, stuff like this. I personally lead a lab on the application of machine learning methods to software engineering. The lab was established 4 or 5 years ago, and the goal was to merge current state-of-the-art practices in the area of software engineering and machine learning. And we are still working on that, but I'd say that currently our research interests are a bit broader than just the application of machine learning. Software development is a complex process involving various people playing different roles and, more importantly, creating all kinds of artifacts. Some of them are known to be important, like source code. Others might be considered more of a side effect, such as code diffs in commit messages or a list of binaries used in your project. For us, all of this is input data, which we mine, analyze, and use to create new kinds of tools, helping developers be even more productive. So as we like to say, we help computers leverage data to help people program other computers. And this surely includes code refactoring, which we are going to talk about today. So my talk will not be about the best approach to recommend refactoring or something like this. We have papers for that, right? In this talk, I would like to discuss the path we should travel from an idea through a research prototype to an IDE feature. I'll try to share our experience on this journey for all of us to learn from the cases where we succeeded and from the cases where we failed. So the first thing I wanted to highlight is that the feature pipeline in JetBrains products is actually somewhat similar to the startup culture, where your main goal is to create a minimal viable product as fast as possible, get the feedback, correct your prototype, get feedback again, and so on. So we have to make an extra step, proving to ourselves that this is a task really worth pursuing. Speaking about our research lab, we are usually at the very beginning of the pipeline. We are fishing for new ideas, we test them, and well, as the best case scenario, we bring them to different production teams if these prototypes meet our expectations. So then these prototypes are transferred to the development stage, where the prototype is usually thrown away or implemented, tested, deployed, and so on. So this is a separate large pipeline, which is a bit out of scope of today's talk, so we'll simply call it development here. But a lot of ideas and even prototypes are put on hold until we get a better understanding of what should be done, or until we invent a new technology with the desired level of quality and performance. I'll share one of such failure cases today as well. Okay, so refactoring. I'll be brief here since I'm sure this is not the audience who I need to convince about the value of refactoring. We all know it's good for your project, for your team, for your karma, and so on. IntelliJ IDEA actually turned 20 years old this year. And I think we can confidently say that a great deal of its popularity, well, this IDE got because of the refactoring tools it contained from the very beginning. So to be extra sure people still refactor code, we have recently conducted a survey involving more than 1,000 paid subscribers of our IDEs. And yes, refactoring is still a common practice. Well, you see, only about 2.5% of respondents did not refactor any code in the last month. And surprisingly to us, 66% of the respondents spent more than an hour in a single refactoring session. So people still need better and smarter tools for refactoring, and therefore more quality research is needed in this area. So there's some work for us to be done. The third thing that I would like to talk about today is the refactoring recommendation task. So there are dozens of papers suggesting and improving all kinds of recommendation algorithms based on heuristics, different machine learning methods, or anything else. And many of these papers report very high results. So when I was reading all these papers like 5 years ago, I kept asking myself the same question over and over again. Why don't we still have features like this in our everyday development tools? So our IDEs are known to help you perform refactoring automatically, but you actually need to sit down, make a cognitive effort, and command your IDE to do this refactoring for you. So refactor recommendation features seem like a reasonable next step to make for us. So the first story is about the project called Architecture Reloaded. Actually, this project was one of the first projects that we started when I joined JetBrains at the end of 2016. There were only 2 of us in the lab, and there were only 2 interns working with us. So it was very different from what we have now. And we were very enthusiastic about applying machine learning to software engineering. So our idea was pretty simple. Let's take the best recommendation algorithm there is, build an IntelliJ IDEA plugin around it, see if we can make it production ready. So what can go wrong, right? Well, we started to struggle with the very first step. In the papers we read, we encountered 6 different ways the proposed approaches were evaluated. So the first one was that researchers manually explored some artificial example or a small project and compiled a complete list of existing refactoring opportunities. So this could act as an example of how the algorithm works, but that's it, basically. Next, the tool is run on some considerably large project, and experts are asked to label each recommendation we get. Since the list of recommendations is usually small, this approach also doesn't require a lot of human effort, but that way it's almost impossible to say anything about the recall metric, for example. Another approach is based on software metrics. For example, we measure cohesion and coupling before and after removing the method. So it could easily be automated, but this approach highly depends on the selection of metrics, which is very subjective. And it does not allow to measure any statistical metrics as well, such as precision recall, since the data set is basically unlabeled. The idea of the next approach is to look into the project histories and collect refactorings that were actually applied by developers in the past. But it turns out that for a whole project, only a few refactoring instances of a particular type are usually found, and not in every commit, which, well, is not very effective, and it's hard to change between versions of this project and so on. Well, this approach, I guess, is the most widely used one. A group of experts is asked to go through some large, usually open source project that mark each data point. For example, say for each method, whether it should be moved away or not. It works well, except that it takes a huge amount of effort to label even one real world project, especially if a researcher wants to have unbiased labels, meaning multiple labels for each data point from different experts. And one popular approach as well is that the approach is based on the assumption that in a real world project, there are way more methods that are placed correctly than methods that should be moved elsewhere. Well, in case of the feature and the code smell. So if we take a random method and move it from its class to somewhere else, feature envy will most likely be introduced. This way, the data set could be gathered automatically, and it could be as large as we need. And I always wondered if this assumption is actually true. But okay, about a year after we faced these problems, a paper came out reporting the data that perfectly summarized the degree of frustration and desperation we had at this time. So in every cell, the tool is the same. It's JDodorant. And the task is also the same. It's recommendation of move method refactoring. But you see, the numbers are very different because of the different data sets they used. So finding the best tool basically was not possible for us. How can the industry adopt the cool results of the research community if there's no way to see which of them work better? Okay, if we cannot find the best ones, let's select the ones that had an open source implementation and we use that. But among the approaches that use machine learning, we found none with existing implementations, trained models, and stuff like this. Okay, then let us select the ones that report decent results and are kind of straightforward enough to implement. We selected 3 of such approaches. I don't really want to reference these papers here since we actually failed to reproduce any of them in our setting. We spent the whole summer of 2017 tweaking the parameters and inventing heuristics to filter false positives. In the end, we managed to build an ensemble classifier based on weighted voting to combine the strengths of these approaches. We created and published an IntelliJ IDE plugin in the marketplace, which got around 500 downloads overall. And analyzing the feedback we got from testing the plugin ourselves and dozens of people we recruited inside the company to try it out, we realized that this prototype is not yet ready to become an IDE feature. So this was a negative result, and to be honest, quite a discouraging experience for a new emerged lab. But okay, if we take a moment to reflect and learn from this story, I'd like to point out the following. Some of you know me as an open source proponent. I have no problem with proprietary code in general. I do work for a company that literally sells software, and some of our research projects that we do are kept internally. But for all the research results we publish, there is always a GitHub repository. And I strongly believe that this is not something unusual. This should be the new normal. Sure, it doesn't solve all the problems. We face troubles with running other people's code from GitHub all the time. But re-implementing and debugging the algorithm from the paper is a waste of time. And it makes me really sad each time we have to do that. Next, not only the source code should be available, but also the data. Oh, in the perfect world, we will have a benchmarking infrastructure for every task that runs the new algorithms against the existing baselines on some labeled data set we have. We made an effort to create such an infrastructure with our architecture reloaded project, but well, we had to discontinue the project for several reasons. So maybe it's time to give it another try. It might just happen so that we have every piece of the puzzle now. I think the second keynote of today could tell us exactly how to collect. It is a data set for that. And the talk by my colleague Zarina that is happening right before the second keynote will highlight the tools we have to build such a benchmark. So if you're willing to invest in this endeavor, don't hesitate, reach out, and let's do together. And the third thing that I wanted to highlight is more of a conceptual nature than technical. So the aim of refactoring is to make the code better, cleaner, and more understandable, right? But when we focus on technical details too much, we might lose the big picture. For example, a refactoring opportunity might be considered invalid because it tries to move a method that references a private field. But maybe we should not get discouraged by this. Maybe suggest a chain of refactoring operations, or just show a hint saying that this fragment of code is so awful that it could benefit from refactoring. So attract developers' attention and leave them to figure out how to make this code simpler. This is the real feedback that we got from the people using this plugin. Automation is surely important, but well, sometimes just finding a smell might be enough. And we definitely have to research more how to find balance of this in practice. Well, this is not actually something new. People have been researching this, but it's just one of the takeaways from this project we have. So moving forward, the idea to turn refactoring recommendation into an IDE feature was reincarnated within our team in 2019. Actually, it was here in this workshop in Montreal where I met Nikos Santalis, and we had several long discussions about research, refactoring, and developing tools. Good old times when we went to places and met people, right? Anyway, one of the things that we discussed is the JDeodorant tool, which I guess, again, needs no introduction here. Surely we also did know about JDeodorant before, but it was something big, dominant, and based on Eclipse. The tool is based on a set of heuristics, so we really didn't consider this approach previously because we were interested in machine learning-based approaches. Well, and to be honest, it was very scary to compete with such a force that dominated in this field for more than a decade. Talking to Nikos about how difficult it was to figure everything out within Eclipse's infrastructure back then confirmed my fears about how much effort it would take to re-implement everything for the IntelliJ platform. It's like 15 papers with their own tweaks and hacks. And migrating the existing code requires getting rid of all Eclipse dependencies first. However, the seed in my mind has already been planted. I got back from ICSI, and sometime in summer 2019, we had a chat with my colleague, Zarina Kurmatova, who is a brilliant engineer and researcher, that it would be nice to get some interns in the fall and try to figure out whether we can do something with migrating the code base to IntelliJ Platform. And, you know, working with the best people has its benefits. Zarina actually dug herself into the existing code base and pulled this through. I was not surprised. I believed in her, but still. We started in September, and in October, 2 interns joined. And by New Year's, we already had feature envy and long method detection as a working prototype. From January to March 2020, we tested the code, tweaked the UI and other things. And then we published the plugin at the end of March. So here I have to absolutely give kudos to Nikos and his collaborators for taking the time and effort to develop and maintain the architecture of JDeodorant. As you can see here, it is quite modular. So the core part almost remained untouched. So we had to rewrite the code that did the parsing, user interface, and like other parts that perform refactoring operations, since we wanted to use the means provided by the IntelliJ platform, and JDeodorant used the ones of Eclipse. We also added collecting user logs. So all the fields in our logs are either enumerable or numeric. They don't contain any binary blobs, free-form text, hashes of your code, libraries you use, or anything else of the sort. We never log what you write in the editor. It would make our lives much simpler, but we don't. Well, in fact, we go the extra mile to avoid logging your code accidentally. The server parses everything we send and discards any entry that includes unrecognized information. Well, our logging policy is that everything is forbidden unless it is explicitly permitted, and many levels of reviews are required in order to change the list of what is allowed. So here's an example of an extract method refactoring being suggested and applied by the user. So for each such event, we record the following: the number of statements extracted into the new method. In the case of this selected fragment, it would be 5. The if statement, the 2 statements before it, and the statements inside the branches. The number of lines in the new method, so the selected code lines and plus the generated return statement. The number of parameters of the new method, so it would be 1, since tick date here would be a parameter. The number of lines in the original method before the refactoring, after the refactoring, and the number of parameters in the original method before the refactoring. So we collect this data just for our information and mostly for catching outliers and debugging them. However, in other projects, this kind of infrastructure is used to collect features for training machine learning models. So if you're interested, please read this series of blog posts about how machine learning is used in our IDEs to empower code completion. Okay, moving forward. So here are the links to the actual plugin and of course the GitHub repository with all the code. I don't put URLs here, so just Google this and you'll find it for sure. So we stopped actively developing the plugin sometime in December 2020 when the last release came out. Basically, we migrated everything that was in JDeodorant, and well, that was it. But this code base surely could be extended with some other algorithms or reused for some similar project. So, well, it could be even the basement of this benchmarking platform I talked about before. So if you are interested in any of that, take this code or reach out to us and let's do something interesting together. Okay, let's continue our story. As I mentioned before, our team is a research lab. So we don't ship features, we don't create products. Our goal is to find an idea, build a prototype, and if we find it worthy, well, we get someone in the production team to fall in love with this idea and carry our flag further. And this prototype, IntelliJ Deodorant, was good. One of the PHP Storm developers, Andrei Sokolov, was very enthusiastic about the whole idea. While working on PHP Storm, the IDE for PHP, obviously, he implemented various refactoring operations. Some of them were quite complex, but our logs show that feature adoption is quite low in this field. Developers might not even know that a particular IDE feature exists, so it remains underused. So after a series of discussions he had with us and some prototyping on his own, Andrei finally decided to switch to working on refactoring recommendation full-time, which he has been doing since April of this year. But before I show the results of his work, I should tell you about the early access program we have for our products. So this program gives anyone who participates free and full access to pre-release versions of all of our software. So it allows you to evaluate new features, test issues that have been fixed, and provide feedback. And at the same time, it gives us the opportunity to test experimental things, the things that might not appear in regular releases. For example, collect logs to see how the new features are doing. And there are usually several thousand people participating in this program, so it's quite some number. There are 3 such EAP releases each year, which gives us free windows of opportunity to put things there, get data or feedback, and pull them back before the release if needed. So if you want your prototype to be tested in the wild like this, come to us. Well, it would surely require a ton of extra work to make it stable, maybe some UI work, but well, I'm saying that it's still doable. You can do that. In the first version, Andrei implemented the approach from the 2011 GSS paper that detected the long method code smell. So this algorithm relies on control flow and data flow graphs to find all code statements modifying some variable or some object property. So the UI was very simple. We have a list of candidates to extract. When you select a particular item, the IDE highlights the appropriate code fragment, and basically that's it. So in the next EAP, they decided to try another approach and use an algorithm that searches for a sequence of statements to extract by calculating software metrics and ranking all the candidates. So this approach allows us to detect more diverse blocks to extract, not only those that calculate the value of some variable. Also, some UX rework took place. A new window for the candidates, for the candidate list has been designed and created with a preview with the signature of a newly created method. So it was a step forward. Here's a demo of how it works right now in PHP Store. So before that, there's a background process that searches for complex methods based on several software metrics. If a method is considered complex enough, this gutter icon appears. Clicking on this button actually starts the calculation, the code analysis, and it takes some time, and 3 best candidates are shown. Well, the number 3 was chosen empirically, since people actually rarely examine more options, and a very long list might actually overwhelm them and prevent even from using this feature. So the extracted fragment is highlighted. Well, we can examine the preview here. When we're done, we'll select other candidates. When we're happy with our choice, we hit extract, and a standard refactoring window appears, which we can use to conclude the job, basically. So here we, again, preview the signature and hit refactor, and okay, we're done. So originally, finding the candidates was implemented as a separate code inspection. So, code inspections are those yellow background, yellow backgrounded code that you can click on and most oftenly apply a quick fix. The problem with this is that some users really get used to the yellow code, and eventually they begin to ignore it. And this refactoring recommendation is a new feature, so the developers wanted to attract additional attention to it. So they used this gutter icon as an alternative. Moving forward. Yep. So here's a screenshot from the latest release candidate of PHP Storm, which everyone can download and use. If you open the list of supported expansions, you can see all of the implemented recommendations there. Some of them just calculate particular software metrics and report methods or classes that violate the limit. The one that I showed on the demo is the complex function one. You can also see that there is another one concerning the feature and the smell, and the one suggesting the pull-up method. Obviously, this is an ongoing project. It's been active for like 6-7 months, and a lot needed to be done. So implement new approaches, analyze the log data, we get improve the already implemented approaches, come up with new UI, etc. And there's only one developer currently working on all of that. But the good thing is that PHP Storm is built upon the IntelliJ platform, along with IntelliJ IDEA, PyCharm, WebStorm, and many other IDEs. Yes, they do differ in some things internally, but when we get something to work for one IDE, it is much easier to migrate it to others as well. So I'm sure we'll see more of such features implemented in our IDEs for other languages, for languages other than PHP as well. Okay, so time for some key points of this story. The first one I wanted to touch on is the angle researchers and practitioners look at the task of refactoring recommendation. Once I reviewed a refactoring recommendation paper that tried to maximize the recall of the approach. The authors backed this with an argument that, well, the more code smells we find and fix in the project, the better the code base would be. From my experience working as a software engineer for almost 10 years and observing other people writing code, this is actually rarely the case. Refactoring is usually not a separate event, such as these code reviews in the pre-GitHub era when the whole team gathered in one room, opened some file on a projector and discussed how to make it better. Well, we do tend to have long refactoring sessions to rearrange some things and make some other features possible, but I never saw people sitting down to eliminate every complex method in the project. Well, maybe this is unfortunate that people don't do this, but it is how it is. And this brings us to the question, what do developers actually want from the refactoring recommendation tool? Is it the complete list of code smells in the project? Or what are the 20 possibilities to split this particular method? From our experience, it would be something much closer to what is the one modification in my project that I can do right now and make it better without actually spending too much time on. And to do that, we need to find the smelliest place as quickly as possible and suggest the one fix and do it interactively. Well, which actually brings me to the second point. It seems like we already know pretty well what to suggest. The less obvious thing is how. The more some refactoring tool will be integrated into the workflow of developers, the greater their adoption will be. Analyzing the logs we get from the users, we see that sometimes people click on the gutter icon that they showed you, they initiate the process, but they don't get to the final point. And well, why are they lost somewhere in the middle? We don't know. I know that people work on this, and we had papers on this workshop exploring the user experience of refactoring and other practical aspects, but I think we lack enough research in this area. There was a great keynote at ICSME by Gail Murphy about a month ago on the usability and usefulness of the tools we use. And she suggested that maybe we should transfer some of our energy from developing new tools into better understanding of how the existing ones work to bring the most value from them. Well, obviously I'm paraphrasing, but this resonated with me. Well, here I am saying that we as a tool vendor are very much interested in diving deeper in this topic. If you are researching the usability and usefulness of IDE tools, including refactoring ones, come to us. I think we can help each other here. And the third thing is more of a technical one. If we're talking about bringing this tool to a real people in an immersive and non-intrusive way, the refactoring tools should be fast, like a matter of seconds fast. No one would agree to wait for 10 seconds for the method or even the file to be analyzed. The ultimate goal is to provide such an experience that a developer understands that their code becomes problematic while they're typing. And bringing all the calculations to the background doesn't really help. It overloads the CPU and drains the battery of the laptop. And well, needless to say that we're limited in memory consumption as well. So in the current implementation in PHP Storm, a lot of work has been invested in such optimizations. For example, the original IntelliJ deodorant code was not used and things were implemented simply because of these reasons. Well, our goal was to obtain a working prototype as fast as possible. So we tried to reuse as much code as we could. And this resulted in creating wrapper objects, which increased memory consumption. Well, currently, we don't have to think about all of this to write a paper, right? We compare our precisions, recalls, and other scores, but performance is as important as the quality of the recommendation algorithm. So my point here is that it would make me very happy to see papers comparing the performance of their approaches alongside with other quality metrics. And it would definitely help to adopt these features by tool builders. Okay. So here we have a story that is not going to be about refactoring recommendation, but about mining refactorings from the version control system and what we can do with this kind of data. Well, I guess this story could act as a warm-up for the second keynote of today, but anyway, I think I might get back to the recommendation part at the very end here as well. Okay, so we have a history in the version control system, and we have some tool that can detect refactoring events within code diffs. So there exist several such tools. They differ in how they do things, but I'm not going to talk about this. I will focus on the application side. So why do we need such tools? In academia, they enable all kinds of empirical research. People study all kinds of stuff mined from the VCS. There's a separate MSR conference for that. Go and check out that program. So another case that already mentioned today is building data sets, for example, to train machine learning models. But we're talking about IDEs now and how this data could be useful for a practitioner. Well, there are data-driven tools that work with code changes, for example, refactoring aware branch merging, or a tool that applies quick fixes based on historical data. All of these tools depend on mining refactoring events. But in this project, we decided to start with supporting code reviews and code exploration. In this setting, refactoring operations are often considered as noise. When you're browsing through the diff of a commit to see what changed, well, sometimes it's hard to see what actually happened because of the refactoring changes. So wouldn't it be nice to have all the changes sorted out and labeled somehow? There's a bug fix, there's a new feature, and here's the refactoring. Well, the last part is exactly what our IntelliJ IDEA plugin called Refactoring side does. So we ran refactoring miner on a commit to understand which changes are refactoring and which are not. Then we empower this data to implement several usage scenarios, which I'm going to show you in just a moment. Here are the links to the marketplace, the GitHub repository, and the paper describing the tool, which is going to be presented at ASE like next week. But you can just Google refactoring side and you'll find all of this, no problem. Okay, let's see how it works. So this is the standard IntelliJ VCS window displaying a list of commits in the project. And here we have a tab, a new tab that shows refactoring changes performed in this particular commit. So we have that, make it back. We see that there are two methods renamed and one method was extracted. So double clicking on that shows a standard diff window that shows this particular change that corresponds to this particular refactoring. So yep, that's it. One of the use cases. And it also works for pull requests if you prefer working with them within the IDE. The second, this is the same. Yeah, the second scenario is more of an exploratory one. So for each method or a class in this case, you can see the refactoring history. So the history of how it's been refactored. So when you click that, a new window appears, for example, in this case, showing that a new annotation, class annotation has been added and removed after some time. So again, clicking on those shows a list of commits, the history, where you can see who did the change, what was the motivation, and when, for example. Yep. Yeah, moving forward. So the prototype was ready and it worked pretty well. So we went to the IntelliJ VCS team to get their feedback. Overall, they were quite positive about the tool, and they suggested that we support Kotlin as well. So refactoring miner only works for Java. It took us some time, but we managed to extend refactoring miner to Kotlin in a library called Kotlin R-Miner. It re-implements refactoring miner's heuristics and refactoring detection rules. It also relies on the embedded Kotlin compiler to parse the code and extract its inner representation. Currently, it supports the detection of 19 refactoring types, which is, well, less than refactoring miner detects for Java, but it seems to be quite enough for our case. They have also come up with a third usage scenario, which, to be honest, is my favorite one. We can make the diff window in the IDE refactoring aware. So we can embed refactoring information into code diffs and show exactly where the refactoring code changes are. I'll show you that in just a moment. They also had concerns about the performance of the end-to-end tool, having to run refactoring miner and stuff like this. But our evaluation on a bunch of open source projects showed that the maximum median time of refactoring side on Java projects was about 50 milliseconds, and on Kotlin projects about 160 milliseconds for commit, which, well, we believe it is quite acceptable for our task. So the drum roll, the modified diff window looks like this. Here we can see that there's a label saying that this method was moved from some other class without changes. And more importantly, there's this folder icon right here. So if we click that, we can fold. We can fold and unfold those methods. So if you are not interested in refactoring, you can fold them and focus on the rest of the code change. So from the technical side, this project required the integration of different existing tools. So architecturally, it was pretty straightforward. We have the mining service that does the mining of refactoring events and handles their storage. It uses commit miner that actually gets commit diffs using the Git4IDEA IntelliJ library and employs refactoring miner and Kotlin R-Miner tools to find refactorings in this data. We also have diff window, which is basically the upgraded diff window, enabling all the hints and folding magic. And this was one large model, which made it impossible for the VCS team to take parts of this project and move them into IntelliJ Platform. So we had to split this code base into several Gradle modules. We made the common component here language agnostic and independent of any specific libraries, such as the Eclipse JDT, for example. There is also the runner module that now runs all this mining and other calculations, and the plugin module, which is responsible for the UI side of things. We refactored the code that represents refactoring in Java and Kotlin, and now they can be used separately and independently of all other code, which is exactly what the VCS team is planning to do. I don't think I can tell the details just yet, but they're working on a new thing, and this refactoring detection functionality will be a part of it. So when you see a feature like this in the new IntelliJ IDE release, you know that you've heard it here first. But again, a refactoring side plugin will always be openly available for the community. Okay, let's summarize and reflect here a little bit. First of all, I'm really happy to say that there are tools created by researchers and which are used by researchers that you can just take and make a part of your product. Well, I'm talking about refactoring miner, of course, not about prototype, which was basically a bunch of blue code. So once again, kudos to Nico, Samea, Danny, and other people responsible for the refactoring miner 2.0. Then, once again, I would like to stress out the importance of working within the developer's workflow. I see a lot of research prototypes that implement their functionality as separate windows, making the complex and difficult to learn and navigate user interface of an IDE even more complex and cluttered. Our IDEs already have tons of features that almost no one knows about, So please don't add your code feature to this list. I beg you, if you prototype adds a new window to an IDE, please think harder. Well, I'm not saying that the current workflow of developers within the IDE is the perfect one, but well, not even close, but this is what people are used to. And our experience shows that it's almost always possible to merge new features into existing tools. So that way you will drastically increase the discoverability and the adoption of your tool. And well, it is definitely hard and sometimes requires us to rethink the whole pipeline, but it pays off. And the last thing here is kind of encouragement to try new things in an unusual setting. So look at the things we know from a new angle, and it might become a foundation of new ideas, things that you didn't think about before. For example, when we learned how to detect refactorings within a commit in an IDE, a very simple idea came to us. So when a developer prepares a new commit inside an IDE, we can actually detect refactoring code changes in this newly created commit and suggest the developer to split the original commit into two, the one that creates all the refactoring and another one with all the other changes. And having our infrastructure, that should be pretty simple to do. Another idea that came to our minds while working on these two projects is that the last two projects is that the VCS information could be pretty useful in the refactoring recommendation task as well. For example, suggesting to fix a code smell in some legacy part of the system might not be the best choice. Maybe no one from the current team even knows how this code works, and there are no tests, and well, it's better not to touch this code at all. Or expanding on this thought, maybe developers would be more willing to accept a refactoring recommendation in a code base they touched and therefore know. Has anyone tried this? Well, I don't know. Even if it was not new, I think you get the point. New perspective gives you new ideas, which I guess is good. Okay, I'm running out of time. I wanted to conclude with this diagram that I took from a PhD thesis of my colleague, Vladimir Kovalenko, and I like this diagram a lot. It shows a life cycle of a data-driven feature in a software engineering tool. So researchers in academia mostly work on data-driven techniques, publishing papers where they compare this new technique with some alternatives. Some people make an extra step and develop a prototype tool providing other people the means to actually use this feature. It requires additional work, sometimes a lot, but to actually make an impact with your work and make this feature a part of the production level tool used by hundreds, thousands, or even millions of people, usually a lot of extra work is needed and some help from the vendor. So we at JetBrains can help you with building tools. Well, I'm not promising, again, that your techniques will become a new feature of an IDE or some other tool, but this is a very complex process. But we can help with refining the vision of what the technique should be and how to reach your users with it. We can help with building prototypes. And if you get there, we can help bring your plugins to the EAP program and test them on real developers in the wild. So please don't be afraid to make these extra steps. It is hard, but I think it's worth it. And here I would like to thank all the people who made everything that I've told you about today. First of all, my thank you goes to Nikos and his collaborators for the years of hard work and very good software they developed. Also for motivating and encouraging us to start these last two projects and the technical support and other discussions we had. Zarina Kurbatova is the main driving force of the refactoring related research in our lab. Do not miss her talk today. It could be very useful to you. And I especially want to thank her for helping me preparing this talk. I think she answered at least a couple thousand of my questions. Vladimir Kovalenko helped us to start the Refactoring Insight project and co-supervised the interns from TU Delft that worked on this prototype on this tool. Andrei Sokolov and Svetlana Zemlyanska are the people who make the refactoring recommendation features in PHP Storm. And I would also like to thank the IntelliJ VCS team for the help and feedback they provided on the Refactoring Insight plugin. And of course, our wonderful interns who were involved in all of the project that's all about today. And with that, it seems like I'm done. Thank you once again for having me here.
Yep, thank you. Thank you, Tim. It was a very insightful talk. Yeah, I'm really happy to see, all this work that you and your teams are doing, and definitely it has a lot of insights for us as a community to learn. And I can see that, since 2019, we've been at least progressing towards, thinking about how can we seriously, implement our tools and make them available for the community and also for the developers. So that's always a good direction to take. So now perhaps it's we have, some time for questions. So please, if there's anyone who had questions, or we have a lot coming, sure, of course, this is good news. So Professor Santalis, you can start.
Thank you, Tim, for another interesting keynote. So I have many points here, but I don't want to take the time for other questions. So one thing that I realized after doing research so many years on refactoring recommendation is that actually the tools that we made, they cover only a small portion of the of what motivates developers to apply refactoring. For example, you mentioned for move method, you mentioned feature envy, but there might be, and there are many other reasons to move a method. The same holds for, let's say, extract a method when you have a complex method. There are many other reasons to extract a method. So what do you think about, do you think this is a reason for like the adoption of the refactoring recommendation tools? Maybe we're not supporting every scenario yet.
Well, I don't think this is a disadvantage. This is a window of opportunity. So yes, surely, I totally agree with you because, well, sometimes I extract a method only for a fragment of code that is only used once because I want to give this fragment of code just a readable name. And calling a method with a readable name is always better than just adding a comment saying what this code does. So yes, there are different scenarios, and I think we will get there eventually. So we have to look at them and well, one by one, I think we'll get there. So this is a very good point. Thank you for that.
So I will address this in my keynote that follows, actually. So please, if you can stay, it would be great to.
I will for sure. Yeah, wouldn't miss it.
Thank you.
Yes, Sridhar, please.
Yeah, hi. Hi, Tim. Thanks for the excellent talk. I was just wondering, like, when the developers do refactoring for the code, what would happen to the non-code artifacts? For instance, like, the README files or the dependencies in the comments and so on. So, of course, like, the refactoring would change the code, but the implications of that, would that have an effect on any of the other non-code artifacts? In your surveys, did you find that? Or do you think, what is your take on, like, how do you deal with this kind of thing? Because if the code is changed, we know that the code is refactored, but why is it changed? The rationale for it, how do we preserve that? And does it make sense to preserve that? I was able to connect with your history thing, but I was just curious to see if there are some observations or thoughts on non-code artifacts or non-code information.
This is a very good point because for example, when you refactor code and you have some data structure connected with some ORM library or whatever, it might, so just refactoring the code it might not be enough. For example, when you're refactoring some public API or something, so you have to. Not every method should be refactored in the same way, I guess. And the thing that you said about the reasons and then connection to other artifacts, I think there's, well, I don't have the answer to be short. We didn't study this in our survey, maybe we should run another survey on this as well. But I think this is a very interesting thing to dig, because well, and I think that it should come from empirical study. So well, I think we should talk to the real people and try to understand. I have my own experience, but it is limited. Yeah, we have to go to developers and see what is the usage scenarios in this case.
Sure.
Yeah,
Yeah.
thank you for that.
Yeah. Thank you.
Yeah, thank you, Sridhar. You know, Sridhar, everyone is asking really like questions to the point today. So we have also Faisal who wants to ask a question. So Faisal, feel free to unmute yourself. Ask a question.
Okay, thank you. Hi, thank you very much. In the slide 23, you mentioned you use algorithm for searching to find a fragment of code. Which algorithm did you use, if you may, to tell me, please? And second question.
Could you repeat the question, please? The last
in
part.
Slide 23, you mentioned you are using an algorithm to find some code fragments.
Yes, it was the Haas paper, Haas and someone else.
Yeah.
Let me find it.
Yeah, it will be nice if you can paste this perhaps in the chat this way.
Oh, I see. The label was under the image, but it was black text on black background. So I will fix that. Here's the paper. Yeah, sure.
Okay, I see it.
I messed up the colors.
Yeah, so it's already on the chat. Second question, please go ahead.
And another question, please. You mentioned using refactoring recommendation tools, okay, to allocate, example, the method or classes that, let me say, highly recommended to be refactored. What do you think, like, refactoring is different than feature location concept? Like, there is a concept called feature location to map source code to the software feature, for instance. Like, what do you think the refactoring tool would be really different than feature location concept, technique or tool, if you mind? Thank you.
I don't think I read enough papers on feature location to have like an opinion on this, but sometimes we find answers to our problems in different domains, and people are, well, trying to solve the tasks. And sometimes if they look at some other task that people are trying to solve, they find some inspiration there. And well, it was multiple times for me. So reading papers is good for you. I guess this is my outcome. But I'm afraid I don't have the exact answer to your question. But I think that from what I know, it might be quite similar. So maybe trying some approaches from this task to refactoring recommendation would definitely be beneficial.
So if I'm allowed to perhaps, just give my thought about this, is that
sure, go ahead.
In feature recognition, we have the whole area of traceability where we can link requirements to source code artifacts, which is a well-established area for requirement engineering. However, in refactoring, we are still not yet there to do that traceability between, how developers want to see their code and how it is actually implemented. That's maybe part of how we document refactoring, whether we do it the appropriate way or not. So that's another area that maybe we have to think about carefully before, so that we can support such feature recognition, for example. That's perhaps my thought. So, thank you, Faisal. Very, very exciting questions, Professor Marwan.
Yeah, sure. Thanks, Tim, for the really very interesting talk and really an excellent, takeaways that you shared. Great job. So basically, I have two questions for you. So, my first question, we actually performed recently a survey. It was mainly with, with government organizations, that include U.S. Department of Defense, about their needs. And we were actually very surprised with this organization. They have actually huge need for large-scale refactoring. So I know what you presented today is more for incremental refactoring, but actually they have really huge need for large-scale refactoring, and they really struggle to find tools. I mean, for for those type of large-scale refactoring that could be including, for example, microservice migration, this kind of thing that requires some very extensive refactoring first. So of course, there is a belief in academia that large-scale refactoring is rare, but actually found through that survey is actually very important in so many contexts, and industries almost crying for this kind of tools that are really missing to enable that large-scale refactoring. So my question is more around what we heard from them about why they think existing tools may not be adequate for this large-scale refactoring. They're always telling us that most of this large-scale refactoring are feature related and mainly business, I would say. It's not really feature, it's business related, and you know this business needs and requirements in general, they're documented in natural language, and then it's hard, I mean, to link, I mean, this business need to existing tools of refactoring, kind of mapping, you know, probably some quality metrics to this business need, and it's really hard to adjust that. So that's one of the main feedback that we actually got. And then the second question that I have, it's more around this idea of mining refactoring, trying to use the history of the refactoring. So basically this is great. And one of the challenges that we faced was more to understand the rationale of this refactoring, because we look at, for example, commit messages, pull request description. In general, either you don't find anything there, I mean, useful, or, I mean, so it's really hard to understand automatically any rationale of refactoring by just looking to documentation or even looking to the quality metrics before and after, because most of the time this is not the real intention of programming that. And again, it's related to the first question, because many of those refactorings are related to the business needs, but currently we all know that in existing research, this is probably, you know, an understudied area. So anyway, I don't know if there are a question, but there are more general insights. So anyway.
Yeah, you know, a thought appeared. So I think that originally refactoring was more of a technical thing. So we need to move a method, or we have to extract a method. But now we're talking about like the broader picture about the refactoring that happens in the minds of developers that affects this architectural things in the project or in the system. And this is way more complex, and well, so there are things to study here as well. And I think this is more high level refactoring. Maybe it's not even refactoring in the original sense, because it might even change some functionality, but it's still like some massive change of code that we need to be reliable. And yes, we need tools for that for sure, and we need to study this. Yeah, thank you.
Thank you.
Any other questions? I mean, we're almost up, but we can sneak one more question if anyone has any more questions.
Oh, if you have any questions, just feel free to drop me an email or tweet or whatever.
Chat.
I will
still have the chat here.
Or chat, yeah. I'll be here for the whole workshop.
Awesome.
I'll send the slides to Mohammed, I guess, or maybe tweet them so they will be available.
Awesome. We'll add them to the website. Yeah.
Okay, that's great.
Sure. Awesome.
So thank you once again for having me.
Oh, thank you. Thank you. And thank you all guys for coming, and thank you for this awesome talk, Professor Timofey. So I think one thing we can do now